Morning. I am Dr. Sathya, working as Assistant Professor in Department of Chemistry, SNS College of Technology. Today we are going to discuss some interesting topic in electrochemistry. We are going to discuss electrode potential. So we have discussed about what is electron potential, where it can be applied like that. So in electrochemistry, what's the electrode potential? We have take two beaker. One is the dipping into the anode part like zinc and other part is a copper. So in electrolyte solution, we can dip the anode and cathode part. It's called the electrode potential. That means in anode and react with cathode, that means loss of electrons, the cathode will be the gaining of electrons. So simply electrode potential is the difference between the anodic part, that metal rod, and with the electrolytic solutions. So here the anodic part is a zinc and cathodic part is a copper, and zinc plate is dipped into the zinc sulfate solutions. So these electrode EMF potential of electrode and the electrolytic solution, this is the electrode potential. First of all, what is meant by electrode? So electrode is a simply one metal rod. That metal rod, that like anode or cathode, it's dipped into the electrolytic solution. So the metal rod is in a anode and cathode. This is the electrolyte. So the two types of electrodes are anode and cathode. An anode where the oxidation occurs, a cathodic part is where the reduction occurs. So these are the electrode. So now we discussed about the potential. So the potential, the kinetic energy, that means in energy, in this diagram, the person will be, it's going the hill area, it's a kinetic energy is high in the starting line, and going to the hill, the potential energy is slightly increasing. At the top of the hill, the potential energy is a high, and again the hill, out of the hill in downstage, the potential energy will be less and kinetic energy will be high. So this is a diagram. What is the difference between kinetic energy and potential energy? So these are points we know about the students and why the engineers study about the electrochemistry and the electrode potential like that. So it's a too theoretical. We need to know about the hydrogen electrodes and difficult to model electrode interface. Battery waste and corrosion cause the environmental issues. These are the we know about the electrode potentials. That's why we need to study the electrode potential. So define, already we discussed about what is the electrode potential. So simply here in this diagram, the electrode potential in the difference between, the potential difference between developed between the metal electrode, that means anode, and the solution of its own ions. That means in electrolytic solution. For example, the zinc rod is dipped into the zinc sulfate solution. The potential difference between anode and electrode, that means zinc electrode and zinc sulfate solution, this is called the electrode potential. So in standard electrode potential is the one type of the electrode potential. This is measured under the standard conditions. That means 1 molarity and 1 pressure, 1 atmospheric pressure conditions at the temperature of 25 degrees Celsius. So it's a relative to the standard hydrogen electrode is called as standard electrode potential. So this electrode potential will be used to find out the other metal of electrode potentials like that. So in this diagram simply so about the standard electrode potential. So this is the separation of charge creates the electric potential difference. That means anode and cathodic parts. This is the electrode potential. So we can in this diagram we can see about the increasing and decreasing order of metal ion. Here we using some standard hydrogen electrode for find out the other metals electrode potential. That's why we are using standard hydrogen electrode as a reference electrodes to find out the other metal ions. So this is a prototype, this is a basic diagram of an electrochemistry, anodic and cathodic part. It's connecting with the salt bridge and it's connecting with the wire. It form some electrode value. And here an example of zinc and copper anode, that in this picture the electric voltage 1.10 is the voltage of the anode and cathodic part. So in real world applications, electrode potential is a basic thing in battery design, corrosion prevention, and sensors and medical devices. In battery design, the understanding the electrode potential, some long lasting lithium ion batteries like that. In corrosion helps design the materials that resist the oxidation, and sensor for using the pH and ion selective electrodes to relay the predictable electrode potentials. So we need to the engineers to feel the purpose of the electrode potential, and how the electrode potential used in everyday life. So this is the understanding motivates the human-centered design approach, such as the interactive simulation, the galvanic cell, and real-time demonstration like the electroplating. In other slides, we have to, in other section, we have to discuss about the electroplating. So thank you to